Assalamualaikum warahmatullahi wabarakatuh and a very good morning I bid to everyone. So today our colleague from Kuliah 4 will present the topic is titanium trichloride as catalyst. Our members consist of Kiroshini, Siti Nabila, Amirul Hakim and Nur Nadira. Firstly, for the introduction, titanium trichloride is the inorganic compound with the formula TiCl3. At least 4 distinct species have this formula. Additionally, hydrated derivatives are known. TiCl3 is one of the most common halides of titanium and is an important catalyst for the manufacture of polyolefins.
So, I will present about the properties of TiCl3. So, as we can see, it is a picture of TiCl3 solution. So, the IUPAC name is 3-chlorotitanium. The molar mass of TiCl3 is 154.225 gram per mole. It has a density of 2.64 gram per centimeter cube. TiCl3 is a red-violet crystal and hygroscopic. The melting point is 425 degrees Celsius if it is decomposed. The boiling point is 960 degrees Celsius. TiCl3 is very soluble in water, but it is soluble in acetone, acetonitril, and certain aminase. But the TiCl3 solution is very insoluble in ether and hydrocarbons. The other names of TiCl3 is titanium trichloride and titanium trichloride. So the next one is structure and bonding. So as we can see at the right slide, it is a Lewis structure for TiCl3, which is titanium as central atom. So in TiCl3, each titanium atom has 1 d electron. The solutions of titanium trichloride are violet. All feature titanium is in an octahedral coordination sphere. Its structure consists of chains of TiCl6 octahedra. So I will pass the next presentation to Kiroshini.
Okay, now I'm going to present about the properties of titanium as catalyst. First of all, catalyst is a substance that increases the rate of reaction while itself remaining unchanged at the end of reaction. In this case, titanium containing catalyst can be divided into organic, inorganic, mixed and complex catalysts. Both organic and inorganic titanium compounds represents the main components of the complex catalyst for esterification and trans-esterification reaction. Titanium dioxide have attracted interest due to the titanium dioxide's nanoparticles' high activity for various reduction and oxidation reaction at low pressures and temperatures. Furthermore, titanium dioxide was found to be a good metal oxide catalyst due to the strong metal support interaction, chemical stability and acid-base property. Next. Homogeneous base catalysts in the trans-esterification reaction have some disadvantages, among which are high energy consumption, expensive separation of the catalyst from the reaction mixture, and the purification of raw material. Therefore, to reduce the cost of the purification process, heterogeneous solid catalysts such as metal oxides were recently used as they can be easily separated from the reaction mixture and can be reused. In this case, titanium dioxide used as a heterogeneous catalyst shows a wide availability and economical synthesis modalities. Next. Sulfated titanium dioxide is one of the titanium-based catalysts. A solid superacidic catalyst used in the petrochemical industry and petroleum refining process is sulfated doped titanium dioxide. This catalyst shows better performance compared to other sulfated metal oxides due to the acid strength of the titanium dioxide particles, which further enhance with the loading of sulfate groups on the surface of titanium dioxide. The higher content of sulfate groups determines the formation of Bronsted acid sites, which cause the acidity of the catalyst. This enhancement of the acidic properties catalyst cause less deactivation of the catalyst. The esterification of free fatty acids and trans-esterification of oils will be conducted using the titanium catalyst at a temperature reaction of 75 degrees Celsius and a reaction time of 3 hours. This reaction yields 97.1% of fatty acid methyl esters. This shows a higher performance compared to other catalysts. This catalyst can be reused too. That's all from me. I will pass to the next presenter, Amirul.
So I will talk about the production of titanium trichloride. Okay, how it produced. It came from the titanium ore, which is titanium 4 oxide that be heated at 900 degrees Celsius with chlorine gas, and it will produce titanium 4 chloride. So to produce titanium trichloride, it needs to going through reduction process by using hydrogen gas, and it will produce titanium trichloride. Next slide. So I will talk about the Ziegler-Natta catalyst. Basically, the catalyst that used in polymerization, and the Ziegler-Natta catalyst is a heterogeneous supported catalyst based on titanium compound, and it usually is titanium trichloride and titanium 4 chloride. Next slide. So the mechanism of Ziegler-Natta catalyst is it involves reaction in polymerization, which is process in which relatively small molecules called monomers combine chemically to produce a very large chain-like or network molecule called a polymer. The monomer molecule may be all alike, or they may be represent 2, 3 or more different compounds. The Ziegler-Natta catalyst take place by insertion of monomers where the transition metal ions are attached to the end of the growing chain, and the double bond carbon is also inserted into the single bond titanium carbon bond polymer with high molecular weight and high ordered structures. So next it will continue by
For the application, the first example that we have is the Ziegler-Natta. Ziegler-Natta catalyst polymerization is a beneficial and versatile reaction for producing polymers. It is used to produce high and low density polyethylene. And the second one is for the titanium dioxide. It is also be used as a photocatalyst and pigment in many sectors such as in agriculture, food industry and medicine. So that's all from us. Thank you.